Hello, my name is Alex and I would Discover Echo. Today, I'm excited to tell you more about the Revolve Microscope. Now, how did this come to be? So our founders worked in the microscopy industry for many decades, and when someone's purchasing a new microscope, they're left with the central question, do they need an upright microscope or an inverted microscope? Our team sat with this for many years, looking to develop a new microscope that allows you the flexibility of both systems. They sat thinking about how there have been so many advancements in technology, from cell phones, TVs, stereos, everything has really jumped forward. But by and large, the microscope still looks the same. Hence, the Revolve was born. The Revolve is the world's first upright and inverted system in one, and it can image in bright field, phase contrast, and fluorescence. So let's talk a little bit about the hardware. Revolve features Olympus lenses, and we have 6 positions on the nosepiece. The nosepiece is also coded, so the software knows which magnification that you're using. Additionally, you have a focus stop here on the right, which has the ability for both coarse and fine focus. Lastly, first thing you notice is we don't use any eyepieces. The benefit here is that we can take fluorescent images in a brightly lit room without the need of being in a dark room. Additionally, everybody in the room can be imaging together. Now that we covered the hardware, let's jump into the software. We're going to start in Brightfield. So here in Brightfield, you can see we're using a circular view, very similar to looking down the eyepieces of a microscope. If I want a square view, I can pinch to zoom, and the scope will give me a square view of the image, and then I can always go back to that circular view as well. We use all LED illumination on the microscope, so I can turn off my light and turn it back on with no warm up or any cool down. I can also draw my light down and draw it up. Down here on these sliders, I have some additional settings, such as adjusting the brightness, darker or brighter, the contrast, softer and sharper. And we're using a true color camera, but if I wanted a black and white image for higher contrast, I can pull my saturation down to 0. We also feature a white balance on the microscope as well. If I want to go back to any of the default settings, it's as easy as double tapping on any of these bars, and it'll bring me back to my system defaults. Now I've made adjustments to my image here. I can go ahead and capture my image just by tapping this button here. And we initially save all the images in the Browse tab on the iPad. Our images are saved in JPEG and TIFF, and so you can take those downstream to do any sort of annotations on ImageJ, Fiji, or any softwares that accept those files. But we do provide you some annotation tools on board on the microscope. Here, I can add my scale bar. Our scale bar is dynamic, so I can move it around wherever I need to. If I were to zoom in, it will also adjust with me as well. I can also do things like do an area measurement and draw around this area right here. And I can zoom back out. Additionally, I can do things like length measurements, and I can draw between 2 points, as well as adjust my font size as well. I can also do things like count different areas and change color for differentiation. And then lastly, I can also point and then add in a label as well. Now when I hit save, the software will save an annotated copy, but it never overwrites the original, so you always have both at all times. If I'm going to export my image, I could do so by hitting the share button, and there's a number of different ways we can do this. We can export using the USB on the side. There's an Ethernet port on the back. We can also network the microscope to take advantage of any sort of cloud services such as Google Drive, Dropbox, and so on. But if the software does look familiar, we are using an iPad, so you do have the ability to airdrop your images as well. All of our images, again, are JPEG and TIFF, so they're Mac and PC friendly. Now, a microscope is often a shared use instrument. And so say you come into the microscope and somebody has changed all your settings. They changed your saturation, your contrast, your brightness, and nothing is how you want it to be. The nice thing about our software is that you can go back to a reference image, and if you hit Info, you can see all the metadata that was used to take that image. Now, while I can certainly copy this down and punch it into the previous screen, instead, I can hit Reuse, and the software will revert to everything that was used to take that image. Great! Now that we've mentioned Brightfield, let's move over to fluorescence. To do so, all you have to do is hit FL in the software, and the microscope will automatically switch over to the monochrome camera. I'm going to move the stage to my fluorescence sample, and I'll also move to my 20x objective. We use a coded nose piece, so the microscope software automatically knows that we're using a 20x. Now in fluorescence, the Revolve has the ability to do up to 4 channels of fluorescence plus transmitted light. Well, the purposes of this, I just have a 3-color sample. To open up my channel, I can just tap this button here, and then I can get my sample into focus. Here we're taking a look at our mitochondria. Over on the right side, I have a couple different controls. I can do things like increase my exposure time. White is all overexposed. You might be used to seeing it without the pseudo color, but I can go ahead and dial that back. I also have the ability to adjust my LED settings, so I can turn my LEDs down or up. I can also turn my LEDs off and on. And to switch between channels, again, I can switch to my Dabby channel to see my nuclear stain, green for my actin. And if I'm happy with my image, 2 fingers on the capture button, the system will automate storage channel on the left and then provide you with an overlay. I can compare and contrast channels just by tapping these checkboxes on the right. And when I'm happy with my image, I can go ahead and hit save. And again, we can save our images in a color JPEG as well as the monochrome TIFF, as well as do our annotations, such as adding our scale bar. Again, our scale bar is dynamic, so it can move around wherever we need to, and it will adjust with us if I zoom in. I can do areas, so I can draw around this nucleus here. I can also do things like length measurements and draw between 2 points. Zoom back out here. I can go ahead and count my cells just by tapping, so I can tap to count. If I wanted to change color for differentiation, I can do that as well. And then lastly, I can go ahead and point and then add in a label. When I hit save, once again, we save an annotated copy, but we don't overwrite the original. Additionally, in our software, you can perform digital haze reduction, which helps reduce haze and increase sharpness in real time. Here we see the DHR set off. We can increase that 1, 2, or 3 levels, helping increase sharpness to any faint or low level signals in your sample. Now that I've taken this image, say I want to measure fluorescence intensity. I can do that within the Revolve software. First, I'll hit Annotate, and say I want to measure the fluorescence intensity of my nucleus. I'll select my Dabby TIFF, and this is our raw data, and I want to measure the fluorescence intensity of this nucleus here. I'll go to Area, and draw around the area of my nucleus, and this will give me my average pixel intensity versus some background here. Now, the great thing about our camera is we give you the full range of pixels. So I can zoom all the way in, and you can see a heat map of all your individual pixels here. So here we move to a thicker sample to demonstrate Z-stack. First, you want to select your channels and make sure that your channels are set to the appropriate exposure times and LED intensities. Once we set the exposure times, you'll go ahead and find your first plane of focus and hit set. And then you'll move through your sample and hit set for the bottom. In our software, if you hit auto, it will use Nyquist to calculate your step size and the number of images, but know that you can do custom step sizes and custom number of images as well. Here we'll be taking 15 images at 2 colors for a total of 30 images. Now at the end of capturing, we provide you a player, which will go through each slice. And we also provide you with a maximum intensity projection, as well as extended depth of focus. Now we finished our upright imaging. But say we wanted to do some live cell imaging in a plate. For that, we would need an inverted microscope. It's easy to do on the Revolve. First, just retract the nose piece. Next, we'll unlock the stage. The stage sits on a dovetail, so it won't fall or anything. And then lastly, we'll pop the button on the back and just help it over. Now we have an inverted system for our live cell imaging. I can remove my insert, and I can go ahead and pop the plate in. But we also have additional inserts for flasks or petri dishes as well. And there you have it. The Revolve is the world's first hybrid upright and inverted microscope in one. The Revolve features 2 cameras, a dedicated color camera for Brightfield, as well as a monochrome camera for fluorescence, Olympus lenses, LED illumination, as well as the ability to do Z-stacks, all in one neat little package that fits on the bench.